Hope the video lesson is going okay. This is still really weird. Would love for you to join me today at Flex Time if interested. Today's lesson is going to be pretty short. The plan is we'll do 2 examples and I'll give you one your turn. There will be a classwork I will also be posting for you today. But I believe today is 4/21. We are doing 5.4 day, who really knows, but I believe it's day 3. And we're covering examples 5 and 6. Our goal, should you choose to accept, which I know you all will, is that we will be able to verify cofunction and reduction identities. I still don't have any whiteout, so I apologize for that. So yeah, that's what we're doing. So first I'll verify a cofunction identity. I'm not sure if you remember these from the start of the chapter, but there were 6 of them. And we will do the one for cosecant of pi over 2 minus theta. And that cofunction is secant of theta. And remember, this is where we had to, in the past, I forced you to flip things around, use odd-even properties, etc. Here we're just going to go straight forward. The one issue we have is we don't actually have a formula for cosecant, a difference formula. So cosecant, what is the reciprocal? Is the reciprocal of what? Sorry. It's sine, right? So as opposed to doing cosecant, we will rewrite this as 1 over sine of pi over 2 minus theta. And then we will use the sine reduction formula, or not reduction, difference. And sine is different but the same, so that means this will be sine of pi over 2 cosine of theta minus cosine of pi over 2 sine of theta. And then sine of pi over 2 is, I know that unit circle hasn't gone away yet, although it's stuck around for a lot longer. Sine of pi over 2 is 1, so we get 1 times cosine of theta. And cosine of pi over 2 is 0 times sine of theta. This turns into 1 over cosine, which is, oh, that's right, it's secant. So we get secant of theta equals secant of theta. Yay. So when we're verifying these cofunction identities, first of all, there's only 6 possible problems I can give you. I've just done one, and I'm going to give you one on the your turn, but that's going to be in a moment. If you're given a secant, cosecant, or cotangent, just do it with 1 over that. Hope that's okay. So that's a cofunction problem. And then I'll give you a reduction problem as well. And a reduction problem just means that it's going to simplify to something easier. So we are going to reduce it into something more, I don't know the right word, because this is still weird. So this example, we'll do tangent of x minus 360 degrees. And shockingly enough, this will equal tangent of x, which is a good thing because it repeats itself every 180. But that being said, we're going to use the tangent difference formula. So we're going to plug it in. We get tangent of x minus tangent of 360 degrees all over 1 plus tangent of x tangent of 360 degrees. So that's the first step. We're just going to plug x and 360 into the tangent difference. Then we'll unit circleize. Tangent of x is just tangent of x. Tangent of 360, that's 0, not undefined. And then it'll be over 1 plus tangent of x times 0. So my final answer is tangent of x, and there you go. Yay! All right, here's the your turn. So after I write this down, please pause the video. give it a shot, and when you think you're ready, continue playing it. Here is the one I would like you to do. We're going to do a cofunction, which means there's only 4 more left to do. Cosine of pi over 2 minus x. That simplifies to be sine of x. So go ahead, give it a shot. Good luck. All right. Did you get it? What do we think? Cosine is the same but different, which means this is cosine of pi over 2 cosine x plus sine of pi over 2 sine x. Cosine of pi over 2, oh, we just did that, that's 0, times cosine of x. Sine of pi over 2 is 1 times sine of x. Oh, what do you know? Sine of x, we rocked it. Hopefully that works. I hope you had a great day. And yeah, that's it for today.